Folks, so this is PMA 121. We're going to perform manual unpacking, and this is quite important. So I'm going to get this file called putty. Let me bring up my virtual machine, and I think I will stubbornly keep using Windows 11 to see how it goes here. And so I'm going to get putty from this link. This is an old version of putty, just the standard Windows SSH utility.
I'm good, Kerry. How are you?
All right, and there, let me...
I have no idea.
I'd mute that person if I could figure out who it is. Anyway, so let's download this putty. Okay.
You're recording, correct?
I am, yeah. And I'll save this someplace. It probably went in the downloads folder. All right, so I have a copy of putty in the downloads folder. And the first thing I want to do is make sure I've gotten exactly the program I wanted to get. Now, I've noticed Firefox seems to have removed the button to close Firefox, so I have to do it down here for some reason. Anyway, so I'll run hash calc. This is one annoying thing about Windows. It doesn't have a built-in hash calculator, but you can download this free utility, hash calc, to do that. And if I go to downloads, which would be student downloads, all right, and putty, there we go. Now when I calculate various hash values, you can see this MD5 is BA7 and I'm BA7, so this file is intact. It's the right file to work with. Okay, now let's just see how putty works. I'm going to go into my downloads folder. All right. And I think I'll just copy it and work with a copy on my desktop because I tend to make mistakes and destroy it. So copy, which for some reason Windows 11 has decided to hide from me, and right-click paste, which it's also decided to hide from me. Paste. All right. So there's my putty. So I'm going to launch it. And when you run putty, I'll tell it to run. And it's just an SSH client, among other things. So you can put in the name of a server like ad.samsclass.info. And when you open, it will prepare to log in. I'll just say yes. And it prints this message, log in as. And then I could connect to the server, but I don't care about that. I just want to control this much of the program where it prints out that message. So that's what it does. I'm going to close it. And now we'll compress it. So we used UPX last time. If I go CD users, I'm going to get to my desktop, and for some reason CD doesn't go home. So users, student, desktop. All right. Now if I do a directory, I've got putty. So I can compress it with UPX, output, puttycomp, .exe, and input of putty. And tab completion is working now. That's good. All right, now it's compressed, so the original putty that was 531K is down to 267K. All right, and now I can check the hash of the compressed file just to make sure everything is working. I got hash calc, and I can just find the compressed file here, and I think I can just drag and drop it. Yep. And then C66, C66. So this file is okay. Now, this file is only half the size of the original putty, but if I run it, it runs just the same. And so what happens is it compresses only the disk file, but it has a loader which decompresses that stuff and writes it into memory in a decompressed way. So now we're going to use PE Studio, which is a very nice utility that automates analyzing a lot about files. Some people don't like it because it's so automated it automatically sends them all to VirusTotal. But for people like us who are not analyzing like live malware from APT campaigns, that's okay. If you were doing a real instant response at a real corporation, you might be worried about that because you don't want the person attacking you to know that you found them. So when you start analyzing their file, you don't want to publicly announce that to anybody. But for practice like we're doing, it's fine. So I open PuTTY on my desktop. All right. And now what it's doing is it's analyzing the file, and it will take a little while. Notice how one engine at VirusTotal has flagged PuTTY as malicious. And this is why, when students tell me that my website is being blocked by some antivirus engines, I'm not too excited because a lot of them make the mistakes of flagging innocent files. So the things to notice here, okay, let's get a second instance of this and open PuTTY comp. So I want PE Studio again. And PuTTY comp. All right, and now the hash values are of course different. Notice here it's got MD5 and SHA-1 hashes of the file. And of course, those are different for the two different files because they are different. In fact, one is half the size of the other. And let me make my window bigger. Come on, is this thing moving or what? There we go. All right, and somehow I've lost my ability to monitor myself. Let me see if I can get that back. I need an instance of, here it goes, good. And I want to go to Twitch. I just want to have a window so I can see what the students are seeing. All right, let me get that up here. Okay, anyway, so let's see what else. All right, indicators show you how many suspicious things are in the file. This one has 56. This one is still processing. If you go to VirusTotal, notice how this compressed version has 11 engines that are regarded as malicious. You see they're calling it, and what they're complaining is that this is a packed file, which is suspicious. And someone says about attendance, no, I did not do attendance yet. I'll do that later. All right. So here's VirusTotal. See, Apex regards PuTTY as malicious, which is pretty foolish, but 11 people, including Apex, regard a compressed version of PuTTY as malicious, and that's a little more reasonable. Anyway, so there's some suspicious features. Now let's take a look at the sections. In the genuine PuTTY, the sections are here, and they are the usual stuff you expect to see. Text, RData, data, and resource. Text is the machine language instructions in binary, which run the program, and these are the data it uses. And the resource sections is other things like icons and images and such. And those are the sections you'd see in most normal executables. But in the compressed version, you'll find UPX0, UPX1, and resource. And that, by the way, is a mistake by the person that wrote UPX. They forgot to compress the resource section. So the resource section sits there pretty much untouched. It's also kind of nice to notice entropy. Entropy is a measure of how random the data is, and it's also what Shannon called information. The maximum possible entry is 8 bits per byte. Yes, 11 engines out of 68 thought that packed PuTTY was malicious. Yeah. And so this is a very high entropy section. The text section is almost completely random. If it was perfectly random, this would be 8. And this section here, data is 6, and this data is only 2, and the resource is only 3. So the data section here might be string variables, just readable text, and that doesn't really use the bytes efficiently. It can be zipped. Another way to look at entropy is there any wasted space that could be compressed? And it says you couldn't really zip this much smaller, but you could zip this quite a bit smaller. Anyway, notice down here, UPX0 doesn't even have an entropy defined because it's completely empty. Its size is 0 bytes, which is very weird. You've got a section of the file that is of 0 size on the disk. And you have another section here that is very high entropy, 7.9. This is completely random. This is compressed data. That's typically what it means. Compressed or encrypted data is usually the only thing that really has an entropy of 8. And then you have the resource section over here, which is essentially the same as the one up there at an entropy of 4. So you can see a few interesting points there. And if you look at the entry point in PuTTY, which is, let's see, where's the entry point? I may not be able to find it in this display, but we'll see it in the next tool easily enough. There's the entry point. Okay, here's the entry point, 550F0, and that is in the text section, I would like to say, although maybe virtual address is 401,000. Yes, and it's very big. So this is included in there. It goes from 401,000 and it's 5B100, so that's 45C. So this address, it doesn't look like it is in there. Anyway, I'm not going to worry about that right now. All right, let's go on and take a look at the imports. The original PuTTY, if you look at imports, okay, you see some of them are blacklisted, some have MITRE. Yeah, here we go. Here's the ones that are blacklisted. These are the API calls. These are Windows functions used, like copy SID and get length of SID. That's getting your security identifier, which I don't know why PuTTY would do that, and they regard that as suspicious. It's on blacklists. I tend to agree. Getting the security identifier of the current user seems unnecessary. I don't think PuTTY is malware, but it just happens to be doing something that looks a little fishy, so it's got a few blacklist marks on it. The compressed version has a shorter list of imports, only a couple on the blacklist, and this is the same as what we saw before. The compressed file is much simpler from a programming point of view than the uncompressed file because all you're seeing is the decompressor, which is a simple little program. This is the full program, which is often much bigger, although in the case of PuTTY, it's only a little bigger because PuTTY itself is a pretty simple program. All right, and so you can find a flag here by analyzing one of the malware samples, but the real fun is OllyDbg. OllyDbg is a favorite tool of Windows hackers forever, used to cheat on Windows games, which, like I mentioned yesterday, is the best way to get started, using good old OllyDbg. All right, so I maximize the CPU window and I open, we'll just start with normal PuTTY. All right, and I go to my desktop and find PuTTY. There's PuTTY. All right. And it's too small to see, so I'll spend a minute making it bigger. I think it's Options, Appearance. There we go. Fonts, Change. And I'll change this to what I always like to use, which is Lucida, bold, and quite a lot bigger, like 14 maybe. Yeah, that looks pretty good. And now that means that some of these panes are not the right size to show all the data anymore, so I'll make them a little wider. All right, so this is the way all debuggers look. And at first, it's daunting, and you look like you're seeing far too much information, but you get used to it. So let me just resize all this stuff. There are 4 fundamental panes here, and I'll go through them. All right, when you launch anything in a debugger, the first thing you do is look in the bottom right corner where it says paused. This tells you that the program is not currently running. This is normal. The purpose of a debugger is you want to inspect the binary layout of a program while it's running, and you might want to modify it. So it loads into memory and stops to let you look at it and decide if you want to change anything. Up on the left, you see the assembly language instructions that will perform the operation. So this is a push, and then there's a move and a call and another push. Those are the instructions that perform the activities of the program. Over here are the registers. These are little memory locations inside the processor. EAX, A, B, C, and D are general purpose registers. This is the top of the stack and the bottom of the stack. And the most important one for us is EIP. That's the instruction pointer. That is the address of the next instruction to execute. Down here is the stack. every time you're running a program, you are usually several subroutines deep, and you see here, the Windows operating system is up here somewhere. This is the list of addresses to return to. So I could return to a kernel routine, and then some base thread thing, and then return to ntdil, which is part of the operating system. These are the addresses that will be used to return when I finish the current process. And in this pane, I can just dump any part of memory in hex and ASCII that I want to look at. So I'm starting with a push 60, and I don't think we're going to... All right, let's look at the memory. If you go View, Memory, you can see the memory segments that are used by PuTTY. And so I'll make this big. And here you are. Here's PuTTY. There are other parts of memory from other processes, but here's PuTTY itself. PuTTY loads at 400,000, which is the default address that every Windows program wants to load at. And then it loads a text section starting 1,000 later. This is not 1,000 really, it's hexadecimal. So it's 1 times 256 to the third, which is more than 1,000. But anyway, it looks like 1,000. That's the text section with the code. Then later on we have the RData, data, and resource sections, which are the data used by the code. All right. Now let's open PuTTY in a second instance of Olly. Yes, tell me about irritating things. Now let's open PuTTY. That's desktop is right. PuTTY comp. All right. Okay, that's irritating. It did not remember my customized view, but it's not too hard to fix. All right. So here, wait, this is PuTTY again. I thought I opened PuTTY compressed. Maybe I somehow opened the same thing twice. PuTTY and PuTTY. I did open the same thing twice. All right. Let's try this again. Open PuTTY comp. Okay, now I'm getting PuTTY comp. Okay, good. Now it notices here a statistical test told it something looks wrong with PuTTY comp, which it is. The code section is compressed or encrypted, so I'll say no. Don't keep struggling to analyze this. You're correct that this program is harder than usual for the debugger to understand. All right, and now if I look at the memory map here, this memory map has UPX0, UPX1, and resource. It doesn't have a text section or a data section, which we've seen before. And if you look what's in these sections, this section has room for 7,000 bytes of code, but if you dump it, it's currently full of nothing but zeros. There's nothing in the UPX0 section at all, and of course, what's going on is all the data is compressed in this section here. If you dump that, that's just, whoops. I think it dumped the wrong section somehow. Seem to be having a little trouble with my accurate shooting here. Dump. There we are. This is really random data, and it's trying to interpret it as code with questionable success. So anyway, what's happening is it's going to run an unpacker and unpack this and load it into there and then run. And you can see that easily if you go back to the CPU window. Here is the executable code, and it's not the same. Let me move this one over and make this one smaller so I can see them both at the same time. All right, and this one, get back to the CPU window. All right, this is the real PuTTY. Push 60, push PuTTY, call PuTTY. Here's the compressed one. Push, add, move, load effective address, push. Quite different instructions. It is not the same thing, and that's because it hasn't been unpacked yet. So if you want, it turns out the unpacker is really small. If I just page down just a few pages, 7, 8, 9, there, 9 pages down, I'm at the end of the unpacker. All this is just zeros. And you can see what it's going to do. All that junk unpacks the code, and here it jumps into the new code with this address. So I'm going to put a breakpoint here. If you select an instruction and press F2, it puts a breakpoint there, which means the running code will stop when it hits that point. So now I can just run the program with this run button. It will run and hit the breakpoint, and it tells you down here breakpoint and what instruction that happened at. And now that it's hit the breakpoint, I can go back to the memory and find the UPX0 section, right-click and dump, and it's all full of data now. And this is the actual unpacked putty. And you can see that, if you like, I can go back to here in putty comp, get rid of the memory map and maximize this. Okay, and now if I press F7, which by the way is debug step into, is the same thing. This will take one more step. And when it takes one more step, it's in here, and now this matches. Push 60, push putty, call putty, move, call. This is the unpacked code, which duplicates the correct code that putty should have. So what I've done is I've now manually unpacked the contents of putty, and this is very important. There's a lot of malware that is packed, and when you run it, it decompresses into memory, but you cannot figure out how it decompresses and decompress it on disk because they don't just use a standard compression unit like UPX. So this is the general way you manually unpack code. You read the code, and this works for all kinds of malware. You read the code, you find the part that does something that irritates you, like decrypt it or uncompress it, and you just use its own code to decompress it, and then you grab it out of memory to see what's in there. So I can now save it from memory. If I go to Window, let's see, Memory Map, View, Memory. So this is the section, UPX0. This now contains the unpacked code, so I can dump it, and I can save it from right here. Right-click, Backup, and Save Data to File. So I can save a file as the unpacked stuff, and that's what you do. And I've got some projects here where you do that. You decompress stuff manually, and then you can find the strings in it and such. This is a quite useful trick. And he says decompress the same as uncompress, unzip. Yeah, they're all just different words for the same thing. When people say unzip, they often mean the specific algorithm called pkzip. And there are a bunch of different compression algorithms, but they all amount to about the same thing. Yeah, gzip is another one. Then there's 7zip. There's a whole bunch of them. And of course, people in malware, they often deliberately modify it in some way just to make it hard. So anyway, that's the joy of manually decompressing stuff. And I think that's all you need to do in this project. Yeah. And you can dump it, and you can examine the dumped file and see how accurate it is. And you'll see that the dumped out file has a lot of the features of the original putty. So let me stop this one.